Hi, this is Linking Out, and welcome to part 2 of my scripting tutorial. This part's going to be about variables. Pretty much, let's get right into it. Variables are pieces of data that are stored in the memory of the computer. So, say if I wanted to create a variable, say local integer. That's actually one of the different types of variables, is an integer. And for that, we'd be storing a number. So say I want to 123. Pretty much what that means is there's an area in the memory of the computer stored, and and it's called integer. That's the name of the area of memory for this code. And if I want to just pull it up, I can just type in integer, and that will go in when the computer runs through this, or when the game runs through this, and it comes across integer here. It will look back, oh, integer is this piece of memory right here, and it will pull up the data from that 123. Alright. So there are many different types of variables. There's the integer. Let's see. There is also the float. Alright. The float is pretty much an integer, except that will also be with decimal points. So say 123.0000. Or, if you needed to do like 123 and a half, you could just put the 0.5 there. Alright, so another type is the string. Local string, and pretty much anything that you have for a string, it recognizes it as a string because of the quotation marks around it, and you could just say cube1. Alright, and another type of variable that we have is the vector. Vector is pretty much just either a set of coordinates or a direction. Either way, it really depends on the situation that it's being used in. Vectors are declared. I need to put a local. Alright, vectors are declared by using functions that create vectors. So I'm going to use the function vector, and in here we have x, comma, y, comma, z. It's easy to remember the order because that's pretty much alphabetical order. Alright, so in the x, I can't just leave it as x, y, and z because I don't have anything called x, I don't have anything called y, I don't have anything called z. If those were their own variables, then I could do that, but for now, I need to put numbers in here. So let's put it at the very center of the map, and call it 0, 0, 0, and that'll be the very center of the map. If I wanted to put it, let's say like 1 above the center of the map, I'd put a 1 right there where the z is. We can see where the x, y, and z axis on here are by taking a look at this map here. If you know your regular graphs from like algebra, calculus, or whatever type of math that you may have done in school, or maybe doing in school, you'll see usually that the y goes along this axis right here, the vertical axis, and the horizontal axis is the x, and that's the same way for the top-down view here. The z is pretty much the height, so as we'll see here, this position, say right here, has a lower z than, say, this position up here. Alright, so let's see. Another type of variable is an array, and pretty much what an array is, see, local array. What an array is, it's a group of different variables. So let's say, keep on missing the backspace. Alright, so you'll use square brackets to create an array, and inside that I'll put say like 1, 2, 3, 4, 5. Actually, let me start that off with a 0. Alright, so when, say I want to pull this back, what I would need to do is array 1, or array 0 would get me the 0th, or the center of the array. If I wanted to pull out the second object in the array, then I would put the first from the center, which would be right here. So like say if I wanted to name this 315 for this first area right here, still the 0 right here would call the center of the array. The 1 right here would still call the first from the center of the array. Alright, and in different programming languages, like say C++, you'll find that if I were to start off with an integer in the array here, then the rest of the array would need to be integers. In Squirrel, I found that actually you don't need to do that. So say I wanted to put integer right here, what this would do this would look into the memory and find whatever is called integer. We found that this is already named that piece of memory, and that would pretty much forward us to the data 123. So right here would store 123 in the center of the array. And so the first from the center, if I were to put float, then that would go and look up 123.5. And the first from the center would be 123.5. So this right here would call out 123, this right here would call it 123.5, and if I were to do array 2, array 3, that would go on to, say if I wanted to do string vector. So let's actually take a look and see what happens when we do that. So array 2, so let me copy that to make this a little faster. I want 0, 1, 2, 3. Okay, I just need to do one more anyway. Array 3. Alright, and this will do, as I said, the center. This will do first from the center. This will do second from the center. And this will do the third from the center. Alright. And pretty much just putting these right here, that's not actually going to do anything. So what I'm actually going to do is print L. That's a function that I showed you last tutorial. Alright, let me just grab that. There we go. Alright, and if I start up Portal, everything's all set up here, so I don't have to run the map, but I'm going to just to open up the game. Alright, so I'm in now, and let's take a look at what happened here. Okay, first I need to step on the button. Alright, and so we see that the first thing was called, the second thing was called, third thing was called, and then the fourth thing was called, or more specifically, the center of the array was called, first from the center of the array was called, second from the center of the array was called, third from the center of the array was called. This is what a vector looks like when it's called. If I were to later change this right here, the integer variable, to something else, that would still stay the same. Actually, let me show you. Alright, don't need that. Alright, let's pull that up here. So let's say here I'm going to change integer equals 1, float equals 1.1, string equals no cube, and vector equals vector 0, 0, 0. And what we'll see here is when we change the integer here, this right here will already be stored in the array, and we're not going to see any change. This float will also already be stored in the array. We're also not going to see any change. So pretty much this right here will still print out 123. This right here will still print out 123.5. The second from the center, the string, is still going to be cube1, so printing the second from the center of the array will also print cube1, even though we changed the string itself to no cube. And the vector will not give this vector, because what this does is this just points to the area of the memory. It doesn't actually recreate it, storing it in its own spot. Or this specifically points to this bit of memory. So like this right here, this copies this right here copies this copies this, and this points to this because the vector takes up too much space in memory to be able to copy it efficiently. So that's just something you want to keep an eye open for. I just wanted to point that out to you. So I'll show you in the game how that happens. So let me just restart here. Alright, and when I jump on the button, we'll see everything is the same as before. 123, 123.5, cube 1, and the vector is 1. Okay, well, when I tested earlier, it didn't. I don't know why that happened. Well, that's something you want to watch out for, at least. That maybe that changed, maybe something didn't go right, but it does do that sometimes. All right, maybe it's a different type of vector that you need to watch out for that for. All right, so let's put this to use. All right, so let's say I want to create a vector for, or not a vector, a variable for, say, a cube that's in the map. This map has a few cubes right here. Alright, so let's create a let's create an array to hold all of these cubes. Alright, so I'm going to create the array and call that let's see, local cubes. Yeah, alright, so I'm going to name that one cubes. It's equal to yeah, let's just leave that as blank. Alright. And then I'm going to put the cubes in there. Alright, so this is going to be another way that you can add to the array. You can use a function. So let's say cubes.append, and then in the argument here we can say float. No, can't put a comma there, but yeah, we can put float. Could do cubes.append integer, and pretty much what that would do is, since there's nothing in there, the center of the array is going to be this value right here, the integer. Actually, no, because we changed the 0th is going to be float. Since we changed float, it's going to be 1.1. Since we changed integer, the first from the center is going to be 1. Alright, I'm actually going to add one of the cubes. So let's say I'm going to add the cube with a function that grabs an entity. So let's see. Entities dot find by class name. Alright, I want it to be the first cube. Each object in Hammer has a value of like which one it is. So say like this right here is the 0th button, or the first button. This right here is the first player. One of these would be the first lights. It would go 1 through 9. I'm not sure which one's first. And of course, one of these cubes will be the 0th or first cube. And pretty much if I were to put the name of, or if I were to put a value that represents the first cube, say like cube 1, that actually wouldn't represent the first cube, but let's say that there was something that represented the first cube, and say that was cube 1. Then it would say that's the most recent one, and that would go to the second cube. And again, as I said last tutorial, you can find each of these functions on, let me pull up the website actually. So you can find that on this website right here. The Valve developer community, just look for a list of Portal 2 functions. And the one that I'm trying to use is find by class name nearest. No, just class name. Alright, and as we'll see in the find by class name, we need the handle and the string. So the handle specifically is what comes before it. Since nothing is going to come before it, and since I'm going to just choose the first one, I'm just going to put null, and that'll represent nothing. Like literally nothing. It's not going to not represent anything. It's going to represent nothing. Alright, and the string will be the name of the class. This will be a prop weighted cube, and that'll be a string specifically. It says right here, string. Oops, wrong button. Alright, here we go. Okay, yeah, and that will pretty much call the first cube and store it in the 0th position of cubes. Alright, so let's say I want to do that again. If I were to do this, then it would also store the first cube in the 0th position, or in the center of cubes. But what I'm going to do here is I'm going to put cubes, and then I'm going to put the center of cubes, and that's going to take this right here, this first cube, and so what this is actually going to do is this is going to pull up the second cube. Alright, so I'm just going to do this for all 4 cubes. Alright, change that to a 1, and that to a 2. Alright, and now I'm going to actually put the cubes, or put a position into an array, so I can pretty much store both and just easily move each of the cubes to the positions that will be in this new array. This new array I'm going to put as local cubes. No, local. I already have cubes. Local position. There we go. Okay, and that's equal to nothing. Alright, and actually, since we already know how we're going to append, I'm going to just put them straight into here. So actually, first of all, I want to find the center so that I can create a place local. So say self, that's going to be, since the button itself is running the script, then when I put self, that's just going to mean the button. Alright, it's if you're familiar with Hammer, that's pretty much just the equivalent of saying exclamation mark self, except exclamation mark in coding specifically means not, so that would just kind of confuse it if we were to try that. So I'm just going to put self dot, and then I'm going to use the function get origin. Alright, I'm just going to store that local. I'm going to store that in self-center. Yep. Okay. So now I'm going to save some positions in here. So pretty much what I want to do is I want to save a position right underneath this light here, another underneath this light, another underneath this light, and another underneath this light. So specifically, say 128 units away in each direction from this button. Alright, so now self-center is the origin of the button. That's pretty much the center of the button. And I'm going to add a couple of positions in here. So let's say for the first one, self-center. Center. It's not working. Self-center. Yeah, I think I got that spelled right. All right. Plus vector. Just a little bit of simple math here. 0, comma 0, comma. Well, that's all right. So first of all, let's see. Where do I want to put it? I want to put it 128 above, and so above that's y plus 128. All right. So y is the second one, 128, and then for the z, so that it's not. Because I'm going to be taking these positions and moving these cubes in, so that it's not going to be inside the ground. I'm just going to place it a little bit over. The cubes, I believe, are 32 tall, 36 tall. 36 divided by 2 is 18, so I'm going to just put 19 above. Alright, so 19. Alright, and so that right there is the center of the array. Alright, so I'm just going to put another one for right afterwards. Let me copy that. Alright, and for this one I'm going to put it 128 below the y-axis, so that's going to be right here. Alright, so let's go here, and pretty much I just copied it, and it's going to be a minus sign right there. Negative 128 on the y-axis. Alright, again. Alright, this time I want it to be 128 on the x-axis. Alright, and then I'm just going to put it on the negative x-axis, so negative 128. This is going to be 0. Alright, so that should be each of those positions. Make sure looks like it's written correctly. So now I'm going to move each of these cubes, because now I have each cube and each position, so I'm just going to put them in that position. So I'm going to get cubes, and then get the center cube in the array, and I'm going to use set origin. Alright, and for the set origin I'm just going to put it as position, and then that'll be the 0th or the center position, which is going to be up from the top-down point of view, right there. Alright, and yeah, I'm just going to copy this and change that. 1, 1, 2, and 3, because there's 4 of them. There we go. And so theoretically, unless of course I typed something wrong, which I might have, when I press this button, it will run the script. It will run these. It will print out everything in the array. It will store each cube in this array with all of this. It will create. It'll store the center. It will use the center to find each position. It'll use the center to find each position. That's this line. I was wondering why that didn't look right. Didn't see the square bracket at the end. Confused me. Alright, and then it will put the first cube in the first position, second cube in the second position, third cube in the third position, and fourth cube in the fourth position. Let's see how this works. Hopefully it does. So yeah, it's pretty easy to miss some of that stuff. That's why I really like Notepad++. Yep, and there we go. We see in each of those positions, Elise is gone. You move it around wherever, ends up back there when you press on the button again. It's pretty cool. That's why I like Notepad++ though, because like you select a opening bracket, it shows you the closing bracket, and vice versa. I'm going to look at that. It's really easy to try to debug stuff. I'll go a little bit more into debugging strategies in a couple of episodes. Next episode will be about loops and if statements, where we'll find easier ways, for example, to collect all of this information here, easier ways to print information in an array. There's just a lot of cool things we can do. So I'll try to get that next week. I don't think that that's going to happen because my schedule is still a little weird and unpredictable, but I'll try to get that out as soon as possible at least. So have a good day. I hope that you learned something from this. Bye-bye.